So let's look at now 2025, a question on electricity. So the question is saying, the following diagram shows a battery connected to an ammeter. This is an ammeter, okay, which has a current of 2.0 amps and two bulbs. These are the two bulbs which are V and W, okay, in an electric circuit. So this is an electric circuit. So it has, this one is a switch. You have a battery which has cells. Then you have an ammeter. An ammeter, now remember, an ammeter measures electric current. So whichever number is appearing on this instrument, this is the current. So 2.0 is our current. Okay. Then you have two bulbs which are connected in series. Okay. So the resistance for V is 1 ohm. Then the resistance for W is 2 ohms. Okay. Then we also have a battery which has 3 cells. So let's look at the questions now, guys. So identify the part labeled U. So this part, this one is a closed switch. This one is a switch. So the answer is switch. Switch. This one is a switch. Okay. Question B. How many cells are in the battery? How many cells are in the battery? So guys, how do you count the number of cells? So a cell looks like this. This is a cell. You have a short pole and a long pole. This one makes a cell. So counting cells, you count like this. A short pole and a long pole makes 1. A long pole and a short pole makes 2. A long pole and a short pole makes what? 3. So in this case, we have 3 cells. We have how many cells? We have 3 cells. Okay. Next, so the answer is 3 cells. Okay. Then question C. What will be the current at W? What will be the current at W? So guys, what you're supposed to know is if you have two resistors connected in series, like in this case, we have two bulbs which are connected in series. In series, the current is the same at each point. So the current at V is 2. The current at V is 2.0. The current at W is also 2.0. So take note, in series, the current is the same. In series, the current is the same. So take note of that, very, very important. Okay? And in fact, this one, our diagrams should be like this. Okay, you need to have a short pole. This one's supposed to be a short pole. This one's supposed to be a short pole. So at when we count a short and long 1, short and long 2, short and long 3. One day I've seen you have 3 cells. So take note of that, guys. Very important. So what will be the current at W? Okay. So remember what I'm saying, in series the current is the same, but the voltage is different. Okay. So the current at V is 2.0. The current at W is also 2.0. So the answer is what? 2.0 amps. This is our answer. Okay. Let's look at question D. Calculate the voltage across bulbs V and W. So they want us to find now the voltage at V as well as what W. Remember what I said? The voltage is different in series, but the current is the same. So the voltage at V and the voltage at W, they are not the same. Okay, so we're going to find the individual voltages at point V as well as what W. Okay, so let's calculate. So let's find a voltage at V. So voltage at point V. Okay, so voltage at point V, we are going to apply the formula for voltage. So you know voltage is equal to current times resistance. Okay, current times resistance. So remember, I'm saying the current in series is what is the same. Current in series is the same. So the current at V is 2.0. Current at W is also 2.0. So we're going to say voltage is equal to current is 2.0 multiplied by resistance at V is 1 ohm. So we say 1. So the current is equal to 2.0 times 1 get 2.0 volts. So the voltage at V is 2.0 volts. Okay. Now let's find the voltage at what? At W. So voltage at point W, we say apply the same formula. So voltage is equal to current times resistance. Okay, so voltage is equal to, and what is the current? Remember, current is the same in series. So we're going to have 2.0 multiplied by, what is the resistance at bulb W? It's 2 ohms. So 2 times 2, okay, that's what we're going to have. Okay, so voltage is equal to 2.0 times 2, get 4.0 volts. So this is the voltage at W. So the voltage at V is 2.0 volts. The voltage at W is what? 4.0. So we are done with question D. Now let's switch on to question E. The last one is saying calculate the voltage of one cell. So they want us to calculate the voltage for a single cell. Now in this case, we know this circuit has 3 cells. Okay, this one has 3 cells. Now they want us to calculate the voltage for one cell. Okay, so now how are we going to calculate this one? So first and foremost, we need to know the total voltage. The total voltage of this circuit. Okay, we need to know the total voltage. Then we're going to divide by the number of cells. So if we calculate the total voltage, we're going to get the total voltage divided by the number of what? Cells. So now let's calculate the total voltage. Let's calculate the total voltage. Okay. So now we're going to say voltage. This is question E. Voltage, let me just say voltage total so that you know. Voltage total is equal to current times resistance total. Okay. Now we know the current is 2.0, but we don't know the total resistance. So we're going to find the total resistance for the 2 bulbs. Okay. So let's find the total resistance. So we know resistance total is equal to R1 plus R2. Okay? So let's move on and say resistance total is equal to R1. We're talking about the resistance at V, which is 1. So we have 1 plus, then resistance 2, we're talking about the resistance at what? At W, that's R2. Okay, so this is 2. So resistance total is equal to 1 plus 2, we get 3 ohms. This is our total resistance. So now I'm going to use our total resistance to find the total voltage. Okay, so we're going to say voltage total is equal to current. It's what? Current is 2. Remember, current is the same. So 2.0 times, what is the total resistance? Total resistance is 3. So 3. Okay. So voltage total is equal to 2.0 times 3. You get 6.0 watt. volts. This is our total voltage, but this is not our answer. Remember, the question is calculate the voltage of one cell. Okay, so we are going to say we are going to say what? We are going to say one cell is equal to 6.0 volts divided by the number of cells. How many cells do we have? We have 3 cells. So divided by 3. Okay, so one cell is equal to 3 into 6 to get what? 2. So we have 2.0 volts. So meaning each cell has a voltage of 2.0. So meaning we have 2 here, we have 2 here, we also have 2 here. 2 plus 2, 4. 4 plus 2, you get 6 volts, which is the total voltage. So the voltage for one cell is 2.0 volts. Okay.